Okay, you should have had a notice that says recording in progress. Please go ahead, Dr. Scott.
Is Stuart going to do an intro?
Okay, Stuart.
I'll just do a brief intro about our organization. My name is Stuart Leibowitz. I'm on the board of the Douglas County Global Warming Coalition, and we're an all-volunteer organization that has been active on this very important issue for the last 19 years. And this is one of a series of Zoom forums that we've been holding this year. Just as a matter of housekeeping, our next forum is going to be on May 18th in collaboration with Umpqua Watersheds, called The Future of Energy, Lessons from the War in Ukraine. But tonight, we are pleased to have this extraordinary Zoom forum that touches not only on the positive solutions that our organization is all about, but also meshes with the importance of developing healthy soils and healthy people. So we're really pleased that Scott McKain, a fellow board member, will share this very important information to everyone. I'll hand this back to Cap.
Yeah, thanks, Stuart. Why don't you go ahead, Scott? I'll just add people as they come on board, and I would just invite any newcomers to mute so that we don't get background noise while Scott is doing his excellent presentation.
So do I need to share my screen?
Okay, let me get you set up. You should be able to do that now. You see that bottom item down at the bottom says share screen. It should be in green. There you go. Well done.
Okay. Very good.
Well done.
So here's our old friend, Albert Einstein, the philosopher of this presentation. We cannot solve our problems with the same thinking we used when we created them. We're talking about industrial agriculture here. We have our two examples to compare: industrial agriculture, imported concentrated fertilizers, herbicides, pesticides, empty calories for the masses, or regenerative agriculture with minimal inputs, much more sustainable, higher quality food, what we call nutrient density. Now, I've never been a farmer. I've never been brave enough to do that, but I'm a pretty fanatic gardener. This is my garden. It is 20 beds, 4 foot wide, 30 feet long, much bigger than I need. All the excess goes to the local food bank. And this shot was taken in 2018, 4 years ago. I set this garden up in 1980. And for 30 years, a rather mediocre result following the organic gardening composting mantra, which is completely unworkable west of the Cascades in Oregon. It just doesn't approach the needs that we have here. And so a few things have happened in the last 12 years that really got me straightened out and on the road to a much better result. One was 12 years ago, my fellow board member in the coalition, Jim Long, told me about biochar. And when I realized what it was, I had a burn pile ready to go, just coincidentally. And so I decided to see if I could get it to make some biochar. And so I did the biochar, and it was pretty unsuccessful. But you know what they say, you learn a lot more from your failures than your successes. And that was certainly the case, because it got me on the road to be doing biochar every year, part of my annual routine. So we are improving it as we go. The second thing that happened was these two books, The Ideal Soil, Michael Astera, and The Intelligent Gardener, Solomon and Reinheimer. These are minerals books. And I call them minerals for dummies because it's just simple arithmetic to figure this stuff out. But for people who live in Cascadia, it is really important, because when I started looking at minerals and testing, which I do every year now, for minerals, you find out that we've got a real mineral problem here. Agriculture is a tough nut in, when you've had 100,000 years of 30 or 40 inches of rain every year, leaching minerals. So these two books are critical. I would highly recommend owning them and having them on your shelf. I look at mine all the time, looking up a particular mineral or how it acts, how important it is to human health. The Intelligent Gardener, Steve Solomon, one of the authors, he's the founder of Territorial Seeds and now a garden writer. He takes Astera's book and reapproaches that information, but he also adds in human health, and with him as the guinea pig. And so it's really interesting reading about what it means to grow food in Western Oregon. Okay. Everybody got those titles written down, hopefully.
Yeah. I just left it on the J.
This shot was taken 2 days ago. And you can see how the soil has changed. Biochar and minerals are the two basic changes that have happened. And in the 4 years since that first picture was taken, things have just dramatically changed. The soils are no-till. It is a firm soil. It is a black soil. It has the consistency of chocolate cake. Quite remarkable. My clay content is only 11%.
Oh, absolutely.
But this soil has a lot of clay-like characteristics to it. So planting potatoes, and we'll bring those up. I'm excited. I've got a new variety this year, and I love potatoes. So biochar there is a history of biochar. The incredible fertile soils in the state of Iowa, probably some of the best on the planet. That fertility is due to biochar and many thousands of years of range fires have built that carbon up in that soil. And that's what we need to do here. And I'll explain more how that works. Also, this is the Terra Preta. the soils of the Amazon and Rio Negro rivers. And this was biochar deposited on purpose by the Native Americans over the last 4,000 years. Well, up to about 1,000, and then, you know, things went pretty south for those folks. But the soils are still there, and any ambitious soil scientist just out of college needs to go down to Brazil and see this because it is remarkable. On the left is the native soil, the natural jungle soil, acidic, highly acidic, leached, 108 inches of rain a year. And you can see the corn, pretty pathetic. On the right is the terra preta, the black soils of the Indians, or in Spanish, terra preta. And they were getting good crops. This is the way you run a sustainable society. Sustainable in the agricultural sense. The char is 1,000 years old and it's still functional, still doing its thing. Now the legend was that there are people who will go to these deposits and fill bags and haul them to the city and sell it as potting soil, which is, you know, pretty cool. But the thing is, in 20 years, they go back to the same spot and do it again because it is renewing itself. And the soil scientists have figured out that what is happening is the char, the carbon in the char is not reproducing itself, but the biology is. The humus and the glomalin, which I will explain later, is growing. And it's being fertilized by the organic stuff that's falling out of the trees and landing on the terra preta. And then the microbes take it in and then process it into humus. And so it's a continuous thing. And you know, when you think about it in nature, that's pretty much the way it works. The organic material, the dead leaves, the dead plants, the dead animals, they're on the surface and the soil knows what to do. So it's a matter of having a little confidence that maybe Mother Nature, we need to give her a little more credit than we have in the past. Now this is my version of terra preta. This is 8 inches thick. You can see the biochar in there. You can see pieces of it. And it has been in there for 10 years. And like I say, I get a mineral testing, which includes organic matter and exchange capacity. Hang on to that term, we'll get there. Organic matter is up 2% over the baseline. And it is composed of what we call stable organic carbon, humus, glomalin, and biochar. That is the three-legged stool. They are all stable. Humus has a half-life of about 50 years. Glomalin, about the same. Biochar is 1,000 years half-life. So it's not on Wall Street schedule. This is a long-lasting proposal. The total exchange capacity is up 15%. I am just real crazy about that. And it grows, just like the Terra preta. Now, if you remember my garden plot and all those plots, 4 foot by 30 foot, they're fixed volume. And so the paths have never been disturbed. And with the Terra preta and in its habit of getting bigger, you can see it. It grows up. It every year it's a little bit higher, and it's to tell you the truth, it's getting a little annoying because I like to keep the garden level and flat because it doesn't lose as much water that way. Otherwise, you know, I would have raised beds, which I'm not real crazy about. So it grows. And so what I am forced to do is, gardeners call this double digging. And I admit this is a violation of no-till, but you know, if you only do it every once in a while, I'm hoping it won't be too bad. So I laid out a tarp next to the bed, remove the topsoil, remove about 3 inches of subsoil, which is you see under here, and it's a tight subsoil. And then I dig raw biochar into the next layer of subsoil. And that will allow roots and fungi to get in there. And then the topsoil comes back, and I leave it a little bit lower than the paths because it's going to come up again. So that's my new habit. And I have removed about 4 cubic yards over the last 4 years just to keep things level. So it's really dynamic. Okay, so I'm going to do a little review of making biochar. It's not an open burn. But it is controlled, and it's my favorite way to do it. It's the way the Amazonians did it, and it works really quite well. It's called the pit method. This is my way to democratize making and using biochar. It costs nothing. I dug that pit in 20 minutes. It's 4 feet deep. You don't want to get it too much deeper than that because you have to get the char out. So that gets a little bit iffy if it's deeper than that. And round is valuable to direct the air into the fire. And you kind of judge how big it should be by how much feedstock you have. That's the waste wood that we're going to be burning. Now, charcoal is created in the absence of oxygen. And so that is what this will do. And I'll show you when I light it on fire here. It is actually baking wood without oxygen. So if you have like a tin can with a little hole in it filled with wood and throw it into the fire where no oxygen can get in, but gases come out, that's the ideal. But it's not very efficient. And it's hard to, yeah, steel containers, some last longer than others, but it's a question mark. Okay, we're going to fill that pit up and light it on top. And that is a nice clean burn. Your neighbors will never know you're doing it. And that's going to burn, it's going to burn the entire pit full in pretty short order. And after that burns down to coals, then we're going to feed it. We're going to keep feeding it until the pit is full of biochar.
Hey, Scott, you have a question in the chat. You might want to watch the chat to explain what glomalin is.
Yeah, I will get to glomalin. Thanks, Chet. Yeah, I'm not controlling that. I'm not seeing the chat stuff. Maybe my. Anyway, yeah, thanks for letting me know. But I'm not seeing it. Okay, so we're going to take some recycled sheet metal roofing that used to be on my house and throw it over the char. It's hot. We're going to seal it off with soil and we're going to wait 5 days. It is remarkable how well soil will insulate that. And I kid you not, it will stay hot for 5 days. And we are baking that wood. And I experiment with even big stumps I've had in there, and over 5 days sitting there at 500 degrees C, it gets charred. It works very well. Okay, there's our product. We're excited. I am. I love doing this. We're going to get the char out. We're going to wear a dust mask. The chemical and physical features of biochar that are wonderful for the soil are terrible for our lungs. The dust is so fine. Wear a dust mask. I have seen wet biochar throw dust off. So please be forewarned. So we're going to move the char to a work area, get it out of the pit. There's a wheelbarrow, works great. Dump it on a piece of unused ground. And I'm going to wash it. I want to get all the ash out. And my habit is to leave it for a year. I let it go through the winter, just like that. And because I'm not in a hurry, I've done this for 10 years, and I'm really not in a hurry to put more char in. I've been putting it elsewhere in flower beds and so forth. It mellows out. Old biochar is better than new biochar, and really old biochar, like Terra Preta, 1,000 years old, it is incredible. So I give it a year. Then we're going to crush it and apply to the soil surface. There's the crushing. Democratizing making biochar and using biochar, no cost if you have a car. We're going to crush it up. And that's on a tarp and it's wet. And we don't need it into powder. I'll explain that. Now it goes on the surface. This picture was taken just a week or a couple of weeks ago. That's my garlic bed. And we're going to put a little biochar on. This is a year-old biochar. And I put it on just for the sake of this picture. Normally I would do this in October when the rain starts. Biochar has powerful attraction to nitrogen. And if you mix a raw biochar into the soil, it will outcompete any plant for that nitrogen. You know, when all people who get into this and really don't understand about it and then dig it right into the soil and start planting, it's just not going to work. But that attraction to nitrogen, we will turn into an asset. The first part of the biochar fraction is the powder, and it will be incorporated by soil life. No tiller required, please. The night crawlers, the redworms, and the incredible spectrum of microbes. We'll be pulling it down as they require. The stuff that didn't crush into powder, little pieces, you know, 1/16 to 1/4 inch, they'll remain on the surface, maybe for a year or two. That's fine. But they will go down, you'll see, and they will turn into a fine powder on their own. It's all very dynamic, but we have to be patient and just have faith that it will work. Now, minerals. All life needs minerals. All of it, please. Some of these nutrients, I use the word nutrient and mineral back and forth because it's the same thing. If we're talking about plant nutrients, it's minerals, right? Okay, some of the nutrients are gases: hydrogen, carbon, carbon dioxide, nitrogen, oxygen are gases. Plants bring them in out of the atmosphere, fix them. This is our carbon. That goes right into us when we eat a carrot. It's great. Quite remarkable. Everything else is in the soil. Which ones are in the soil will vary depending on your location. Some countries have discovered that they are so deficient in a particular mineral, it actually impacts their population health-wise. That occurred in southern China and Australia. In the case of selenium, and coincidentally, the Pacific Northwest. So that's just one example. So the mineral content of the soils depends on the rocks that were broken down to form the soil and the precipitation, how much rain you get, and that which leaches. And you can tell if you have leached soil when you get a soil test, because the highest percentage of minerals are the ones that don't leach. In our case, calcium is half of what we would like to see because it's been leached out. So, and that is true for a lot of these. The yellow ones are the bulk minerals, phosphorus, sulfur, calcium, magnesium, all the biggies. And then the green ones are the trace minerals. Sometimes it's a little tricky to get those. Okay. We want them all. So let me explain to you about exchange capacity. This is the soil solution, water, right? Water with dissolved minerals. Those minerals are available to the root hairs and the mycorrhizal fungi, which transport them to the root hairs. That's a team activity there. But because they're in solution, they can also be leached. And so in Cascadia, by spring, we're leached if we've had a good winter. And so if it wasn't for the exchange capacity, we would be starting at square one. But we do have exchange capacity in the soil, and that's provided by clay, humus, and biochar. Humus, yeah. I only have 11% clay. I don't have a lot of it. And as it turns out, compared to humus and biochar, it's a minor player. But it's nice to have. It stores water also. And this cartoon here shows the material. Those three items could look like this. Minerals, both positive and negatively charged, will stick. It's called ionic attraction, which is kind of a neat word. And it has enough attraction to resist leaching. And the more, and it is imparted by the surface area of these three materials. And the more is better. The more surface area you have, the more minerals you store. And those are still there in the springtime. So you're ready to rock and roll come March. And far less fertilizer. Just a real big boost on the budget. Okay, here is a chart showing the cation exchange capacity. This is half of that equation. And then you have the anion exchange capacity, which isn't shown here. And you can see these soils down here, the sandy loams, which is what I have, the loamy sands, I love that. Silt loams, clay loams, it's a little bit better. Hanging on to those minerals, pretty minor players. Finished compost, now we're getting somewhere. Finished compost is doubles it, finished. But that's still got a lot of decomposed plant material in it, which isn't contributing. This finished compost is traveling in this direction. It is becoming soil humus. Now we're into the stratosphere. Soil humus is the pot of gold. It's not decomposed plant material. It is the end product of the microbes that did that. This is a protein and carbohydrate. It is a weird, mysterious substance. And it takes time to get there. So if you have a compost pile, be patient. Give it time, 1 year minimum. Okay. And here is our friend biochar. Biochar has the highest exchange capacity of any known substance. And it's all around us. You know, you can import, you know, this clay here and maybe boost your exchange capacity a little bit, but my gosh, look at this. This is exciting stuff. The biochar will develop its exchange capacity when it's exposed to nitrogen ions, ammonium and nitrate. That's the cation and the anion nitrogen. And that's why plants can't compete, because that attraction is powerful. So getting the biochar saturated with the nitrogen, we're ready to go. And what we've learned from the terra preta is that the exchange capacity increases with time. So in 10 years, you saw what I have got, and the exchange capacity is measured by the soil test, and it is going up. It's up 15% in 10 years. So that kind of gives you an idea of what the Amazonians were dealing with and how they began to realize what the potential was. So my soil down here is 22 milliequivalents on the scale. And it's pretty low yet. I look forward to the day when it gets up to 50. I doubt if I'll ever need any fertilizer anymore. Okay. Now, the fungal network. You know, with the advent of science to run genetic tests on soils was the dawn of a new era in agriculture. And it really is the start of what I'm describing here. Because what they have found is if you can take a sample of soil and run a gene scan on it, there are so many species of bacteria and fungi and other mysterious organisms that they didn't even know existed. 5,000 and counting are functioning in a living soil. And when people learn that, you know, we're thinking, maybe we shouldn't rototill this, which is exactly the right conclusion. Because we know that soil disturbance dramatically changes the viability of that living soil. Leave it alone. One of them is our good old friend, the mycorrhizal fungi, and it increases the root surface area by 50. And it is at one end physically plugged into the root. So it's an extension of the root. It is a symbiont. And it goes out and it is searching for minerals and water. The deeper it can go, the more water it can get. And it works for free. And it doesn't need a pump. Pretty nice. Now, the mycorrhizal fungi expands and contracts. It grows in a certain direction and then abandons that and grows in another direction constantly. And when it abandons a branch, That dies and leaves a deposit of glomalin. And this is an organic substance. It's another protein carbohydrate combo. Has a half-life of 50 years or more and can accumulate up to 20% of the carbon in the soil. And it stays. So we're building carbon there. We're building carbon in the humus. We've already got the biochar in there. The biochar has acted as a biological catalyst. It is the thing that started this whole process. So sequestering carbon with biochar is only the first step. Once the living soil starts to ramp up, and it's slow at first, it's like a bank account, 1% plus 1% plus 2%. It really starts getting in. Like I say, I'm into it for 10 years and it's really starting to go now, and I'm really excited. You know, it's really quite remarkable. Now, what happens if this gets disturbed is it takes several months to recover. So, you know, really, we don't want to disturb it if we can help it. And that's why I'm a little bit, I'm thinking hard and long about how I have to level my garden every once in a while. Maybe I may have to abandon that whole design. I don't know. Okay. So mycorrhizal fungi loves biochar. There is, this is a fungal spore. And then you can see these fungal root-like gizmos called mycelium. And they are diving right into that biochar. Why do they do that? Well, they are physically protected by their predator, which is nematodes. And here's a picture of it. Here's the mycelium. There's the nematodes having Sunday dinner. And the mycelium would prefer to be in the biochar. Having the biochar allows the fungal biomass to increase significantly. And so then the glomalin builds. So that's why the biochar is, like I say, started this whole process. Okay. Here is an example of how a fungus really likes that biochar. And it's nice. This is a great picture. That's not mycorrhizal because that's a mushroom, and mycorrhizal don't do that. But you can see that it really is focused in on that piece of biochar. Yeah. The relationship between biochar and fungi is long and deep. Here's a mycorrhizal fungi on a root here. Here's the spores. You can see the mycelium. They are actually in the root, or in the root hair. So that's symbiosis at its best. Okay, water. The Dry Farm Institute is a nonprofit organization began by Oregon State University Extension. And they have become renowned around the world for experimenting with techniques in dryland agriculture. And my inspiration got me experimenting my inspiration from them. So I now grow tomatoes, potatoes, dry beans, cowpeas, and squash with no water. And it works beautifully. If you ever had dry farmed tomatoes, try it. They really are extra sweet. Now, what I have heard, and I put a question mark around this, I've heard that somebody at the Dry Farming Institute is working on a machine to inject a biochar slurry into the subsoil. Now, why would you want to do that? Well, if there's biochar in the subsoil that has been impenetrable before, and now it has biochar in it, that is going to give access to a lot more water deep. And that is, so I was inspired when I learned about that, and that is why I am doing my double digging includes getting biochar into that subsoil. And I'm really looking forward to this fall when I can dig up some of these plants and see if they actually got into it. But the water issues here are becoming acute. And so there is if you go to their website, check it out, see who they are, their experiments, their on-farm visits. You can go to a bunch of, I haven't gone to one yet, but I intend to. Anyway, they're out of Corvallis. Very interesting stuff. The thing about dry farming or dry gardening is it takes a lot of willpower not to water. Because if you water, the roots go sideways. And rather than down. So when these crops are planted, you just have to grin and bear it. You can't believe it. You just walk away and hope for the best, and it will turn out just fine. Okay, now, recipe for nitrogen fixation. This is 4 years ago was my next step in my education. Because I learned serendipitously that I was deficient in a mineral called molybdenum. And I have a heck of a time saying that, and molybdenum is critical for fixing nitrogen. Now let me explain how this works. If you've grown a legume, like this legume here, you have these nodules on the roots. Now, for 30 some odd years, I was growing fava beans and I'd get, maybe 50 nodules or so. And I thought that was normal. No, I was way behind. If your roots don't look like this, you may have a molybdenum deficiency. And I really wonder if maybe the whole half of the state does. I just don't know. So molybdenum, we're going to measure it in parts per million. 1 part per million is the minimum. My soil sample test results came back 0.2 parts per million, which was almost non-existent. I was lucky to get any fixation at all. This is the secret sauce. If you don't have it, you will not get any nitrogen fixation. Free nitrogen, free fertilizer. Molybdenum is cheap. A couple of bucks, you're on your way. You do need the correct bacteria for the plant that you're growing. This is a clover. This seed comes pre-inoculated, so you don't have to buy a separate inoculant. But if you do, it comes in a little package like this, and you can go online and find a vendor. It's not expensive. And here is the reason why. Nitrogenase is an enzyme. These are the nitrogen fixing bacteria species. The rhizobium is the one that's on the root nodules or inside the root nodules. So it's a symbiont with a legume, whether it's fava beans or clover, vetch, there's a bunch of them, peas, beans. This is the guy, but they come in different varieties. They're anaerobes. They don't like oxygen. Oxygen won't kill them, but it takes energy for them to neutralize any oxygen that comes in close to them. The reason is the nitrogenase enzyme will be destroyed by oxygen. So they handle oxygen two ways, either chemically or physically. They find a spot where they can control the oxygen from getting at them. And a root nodule is one way to do that. So they're in there. And by the way, biochar is another way. There are anaerobic spots in a piece of biochar. And I don't have any evidence of this, but I have a sneaking suspicion there are anaerobes in that biochar. Now, molybdenum. This is a typical organic tinker toy version of a molecule. Blacks are the carbons, nitrogen, sulfur, iron. Those are our minerals. We need them. The greens are the molybdenum. No molybdenum, no nitrogen fixation. Okay, what is nitrogen fixation? Well, these guys, these bacteria, they take in nitrogen out of the air and turn it into the ammonium ion. It's fertilizer. It's like, ammonium sulfate. Better than buying it, right? It's happening 24/7. And it is self-regulating. If the nitrogen level is low, it is working overtime, this enzyme, these bacteria. Like in the spring, things are warming up. These guys are jumping into high gear. As the nitrogen levels in the soil increase, it slows down. And when it's really happy, it stops. Now, like I say here, higher nitrogen in the soil inhibits the fixation process. And if it's really high, like from a concentrated fertilizer, will kill the bacteria. So that is why using concentrated fertilizers can be addicting, because once you've killed off the microbiome, you're stuck. you either have to drop back to square one and re-inoculate the soil. Better not even dink with it. You just need to understand the dangers. Okay. Now, I wanted to talk about one cover crop because I'm so excited about it. This is a new kid on the block. Not sure how long it's been around. It hit Territorial Seeds about 4 years ago, and that's where I first noticed it. And I thought, wow, it fixes 250 pounds of nitrogen per acre. I got to try this. And I've been experimenting with it ever since. It'll put a taproot down 18 inches according to the literature. Now, when I'm double digging, I actually dug some Balanza Fixation, it's called, up, and the roots were into the subsoil. I was just thrilled with that. So a lot of potential here and a huge amount of biomass. And I have a hunch that this would be a great cover crop for land restoration. It is just going to outcompete everything. It grows 3 feet tall, and the bees just go nuts for it. So, and it is a winter cover. So it is an annual. We saw it in late September. It haven't rained yet. Go ahead and irrigate it. We need to get it going. And then once it's up, that's when I put on the biochar, because biochar will stimulate the nitrogen fixation because it has sucked up all the nitrogen, and the clover says, whoa, we need to get going here. So it'll go into the nitrogen fixation part. And so then, you know, and you've got biochar, a little bit of biochar underneath all this biomass here. And then we're going to cut it. I use a brush cutter. If you're a farmer, you've got equipment that'll do this, I hope. I'm not real familiar with all the equipment that is out there, but we don't want to disturb the soil. We just want to cut the tops, cut the green stuff. And that's a bunch of fun. I like doing it. And then we're going to sheet mulch it. No work or very little work. Cool and moist becoming more of an issue for us. You know, we got the next heat dome. This is an issue. I like cool and moist. Conserve water, of course. It is protecting the soil. Food for soil life. This material will disappear in 4 to 6 weeks. Soil life knows what to do. You don't need to tell them. You don't need to pay them. Between this mulch and the soil is where the worms breed and lay eggs. Lots of food for the little babies. And those night crawlers, go out at night with a red flashlight and see if you can see some. That's a hoot. They're huge. And the whole process is less work. Now in the future, this winter, I'm going to add to the Balanza Fixation clover, I'm going to add some rye, some cereal rye, because the clover is not hard, it's slow to get started. But the rye starts right off. And so that'll be a good combo. And in this situation in spring, when I cut this, the rye will last longer on the surface. So that'll give me a more of a mulch as the summer progresses. Okay, I have one more slide. And this is a study that was published by the International Biochar Initiative just a couple of months ago. And it is public in the public domain. And it is what they call a meta study, which is a bunch of different studies that they put together, averages and so forth, to look at the effects of biochar on biology and chemistry. And this is a straight A report card. It is remarkable, and a lot of it is surprising. So plant productivity, crop yield, photosynthetic rate, water use efficiency, available soil water, root biomass, root length, number of root nodules in the fixing nitrogen, soil microbial biomass carbon. I don't know what FL or PLFA is. Bacteria, fungi, soil microbial biomass nitrogen, soil organic carbon, available phosphorus, plant nitrogen uptake. All are improved, some dramatically, from biochar. The soil organic carbon is important because that's on its way to form humus. Look at that, 40% improvement. We are sequestering carbon big time. The other interesting effect from a greenhouse gas angle is nitrous oxide emissions. Biochar in the soil will reduce those 40%. No, 40%, almost 40%. Nitrous oxide is 300 times more powerful than carbon dioxide in trapping heat. This is an issue. This is a big issue. And it is the result of excess nitrogen fertilizer being used in agriculture. It is very easy to overdose on nitrogen when you're using it out of a bag. Nitrogen fixation, on the other hand, is self-regulated. So a big plus to depend on the biological fixation of nitrogen rather than the chemical version of it.
So Scott, just quickly, there was a question asked by Melanie. Could you review how we can use biochar in our gardens and prepare it so it doesn't compete with the plants?
Yes, I can do that. Okay, one other thing on this chart, reduced heavy metal concentrations in plant tissue is because it gets locked up with the biochar. So if there's heavy metals in the soil, people are using it for reclamation with biochar, contaminated soils and so forth. This is a good thing to be aware of. You don't want to be gardening on an old mill site. Who knows what's in that soil? Pollution, I'll tell you, it is an issue. Okay, Melanie, let's see. I'm going to go back to there. We are going to apply biochar to the soil, and that's it. Do not dig it in, please. You don't need to. If you put it on in the fall, you'll get the rains, you get the worms, and you get the biology, and it will appear in the soil deep over time. So we're just patient. It'll be there doing its thing, getting charged up with nitrogen from the clover, the dead clover that we just cut and left on the surface. And so this would be covered with dead clover biomass loaded with nitrogen. And the worms are just going bananas here, eating all that decaying clover, dragging it down their holes, along with the biochar. So, you know, it's, and I do this every year. So it's just routine, a very enjoyable routine, because I know what's going to happen. Does that answer your question, Melanie?
Yes, thanks.
Yes, thanks.
Okay.
So
Now,
are you
is-
ready for questions, Scott?
Yes.
So folks who have questions, why don't you unmute and ask your question? Folks, questions for Scott?
Yeah, I have a question here. Scott, I wonder if you've ever had any problems with or solutions with raccoons going after your worms in your beds.
Yes, constantly.
Yeah.
Yeah.
So how do you deal with it?
Well, first of all, I have a deer fence.
Gotcha.
That helps, but they climb it or they dig under it.
Yeah.
And it's not only raccoons, it's also skunks.
Oh, yeah.
And every morning, you know, you see evidence of it. I don't know what to do. I really don't. It hasn't been a major problem, but every morning I have to go step on a, you know, you can see where they're digging in, and I've got some flowers planted, and I was upset this morning because one had dug into some of the new, where I'd put in some seeds. So, you know, we try not to get too worked up over it, but yeah, they're there.
Yeah. You know,
And actually that is, worms are an indicator species of a healthy soil. So feel good about that.
Down there, it says
yeah, you know, Steve Rehnquist in the Master Gardener program. Talked about the bird netting, that the coons don't like bird netting, and I've thought of stretching it over the beds.
Yeah.
And putting it out so you could remove it easily to work in the bed, but so you could foil the critters that come in at night.
There's no camera here.
Yeah, I was into that before I had my deer fence for the first, 25 years of gardening.
Raccoons go over and under.
Oh, sorry, I have my microphone on. This is Ken
Oh.
Carloni here. And
Hey, Ken.
Jenny and I have had good luck keeping varmints out with just a cheap $20, $25 party laser that you can buy on Amazon. If you have a place to plug it in, shine it on your garden, and all the little green and red dots that hit the garden look like predator eyes. And so far, so good. It's worked for us, especially keeping bats out of places that we don't want them. And so far, so good with raccoons in the orchard. So you might
Wow.
try that.
What is it exactly, Ken?
They're the little party lasers, that we shine up in the trees at our party.
Oh, yeah.
Yeah, so you just shine them on your orchard, and at night, just get a little sensor that senses light and dark, so when dusk hits, they come on, and then they go off in the morning, and all the little dots just freak them out. And we've had great luck with that so far. So you might give it a try. You can order them on Amazon. They're just little party lasers, you know, to make little light shows on your dance floor. And the raccoons and the critters generally don't like them.
Ah,
So, so Scott, here's a little question from Sandy Lyon. Can you
Yes.
share any information on how this can be or has been scaled up for use on big fields? And then Jenny Council said, we learned the hard way that snakes can get caught in bird netting if it ends up on the ground.
Yeah, I have, when I was using a commercial bird netting, which is a woven fabric with about 1/2-inch holes in it, and over my blueberries to keep the birds out. I go out every morning to check it because I have caught snakes in it. And snakes only have one direction, and that's forward. They don't know how to back out. So they get their head through, you know, one of the holes, and then they're trapped. So you have to go out. I've rescued two. One of a third one was killed and eaten by a raccoon before I could get to it. So that's, you know, that's life in the fast lane, I guess.
So how about, can you share information on how this can be or has been scaled up for use on big fields?
Are we talking biochar here?
Yes.
Yes. Yeah. We are, if you go online, there are manufacturers of biochar. They can deliver a 18-wheeler full of biochar, and the financial end of it is I am not familiar with. I do know that if it's a for-profit operation, it would be tax deductible, but it is an investment. It's definitely an investment, and even small farmers could do it just the way I do it. You know, you've got waste wood, and just you know, dig a pit and make your own, and just do it every year. But large operations, we are holding our breath on carbon credits, and we will see how that plays out. But that could be, that could offset some of the expense of the biochar. But yeah, we'll see what happens at the federal level.
Okay, so we have a raised hand from Jenny Council. Jenny?
We have a raised
Hi, so back to the biochar. Can you hear me?
You need to mute.
Let me try that again. Is that better?
Yes.
Very good.
Okay. So back to the biochar. So you've got your big hole, and you did a starter burn at the beginning, and then you said you fed more of the feeder wood in.
Correct.
And but you're just putting it over the coals, but you're not burning that next. You're just refilling it a second time.
Well, it's when the first burn here, all this stuff will reduce in volume fairly quickly down to coals.
Yeah.
And so it'll be down, it'll only be half full at that point. So then we're going to take this brush here and put it on and feed it. So if you're feeding it too fast, it'll smoke. So it takes a little time, maybe an hour or so, and feed on top until it burns down to coals, and then go again until the pit is full of char. So yeah.
Okay. So you're burning the whole time, and then but it's only the surface layer that should be burning. There should be coals staying underneath it.
Exactly. And the oxygen or the air cannot get to those coals, so it's preserved.
Okay.
Oxygen will turn coals to ash, but if the oxygen can't get to it, then it's preserved, and they'll be
Okay.
hot. They'll be in red to orange color, which is 700 to 800 degrees centigrade. And that's the temperature we want. We want it hot. This is a hot fire. And the soil with the insulating abilities of the soil, it gets hot fast. And yeah, that's
So
good
how big a
quality
pile do you
char
think you
then.
can burn into a hole that big?
I'm sorry?
How big a pile, how big a wood, a slash pile would you use in a hole that big?
About, if you have the hole should be about 1/3 the volume of the pile of wood. So it'll, to get it all in. So this pile in this picture would probably stretched out to about here. And yeah, and it'll take an hour or two to get it processed.
Great, thanks.
So Scott, basically you're just gonna fill that hole up with coals, and when you get it full of coals, you cap it. Is that right?
That is correct.
And I've seen biochar workshops where people, hosed it with a fine spray of a hose, water.
Yes.
Is that recommended?
You can do that, but it'll cool it down a little bit. And if you're, if you want it to stay hot longer, I don't do that.
Yeah.
But, it just depends. Now this is a stationary, obviously a stationary method of doing this. Now, if you're out in the woods making biochar, you need a mobile unit, a steel unit, and the Forest Service doesn't like you digging holes anyway. So, so you have your slash piles, and you take the kiln, the steel kiln, to the slash pile, and do it that way. And then you got to have water, which can be tricky sometimes if you're way out in the sticks. No pun intended. But this is what we call a dry snuff.
So will crushing bags of commercial barbecue charcoal bring the same result?
It will not. Charcoal for barbecuing is a low temperature char. It has a very low exchange capacity, all kinds of tars and terpenes and stuff, which makes for a nice heat for a barbecue. But the exchange capacity is not there. That is produced at about 400 degrees C. We want double that heat to get the exchange capacity up. So, good question though. A lot of people ask that.
So other questions for Scott?
Are there any outlets available where you can get like, large bags of it, like gunny sacks full at a reasonable price, or is it best to make your own?
The answer is either way, yes. Now, Kaplan went down to Biomass One and got a load of rogue biochar in White City. And he can tell you all about that. I've been down there. It's quite an operation. They are manufacturing biochar using the heat to generate electricity. Quite a remarkable thing. And you can buy, I don't know what the smallest quantity is, maybe a cubic yard.
Yeah, I think the smallest is a yard, and then I think they have 2-yard bags, or did when we got ours a couple of years ago.
Yeah. And, you just need a pickup. And you give them a call in White City, and see what they get for a 1 yard bag. The Douglas County Co-op has it in a 1 cubic foot bag, but it is spendy. And, you know,
And what's the outfit in White City?
it is called Biomass One.
I just put it in the chat, Steve. They have 2 branches of their Biomass One generates electricity from biomass.
Wow.
And then the waste char that's left over in their boilers, they have a proprietary process to fish that out. And last I knew, it was about $120 a yard. Does that ring a bell for CAP or other people who have bought it?
Yeah, I think when I got it a few years ago, it was like 95, but that seems right. Yeah.
And, you know, in the biochar universe, that is an absolute bargain.
Yeah.
For what it does. It's a one-shot deal.
I think they would be open if folks, Scott and I have talked about this, if there was a lot of people interested, they might be interested in a larger order, a truckload order. But, you know, in my discussions with them way back when, a few years ago, they said, well, you know, yeah, maybe. So it's really one of those things. I think we'd have to approach them and say, hey, we're interested in, you know, a whole flatbed of these. What price could you give us?
Yeah.
Yeah.
Now I have talked to the purchasing agent at the Douglas County Farm Co-op, and I suggested that they drop a couple of super sacks out at the fertilizer plant, and people could just take a 5-gallon bucket and fill it up for $20 or so, but I don't know if they'll ever respond.
Yeah.
So when you call the co-op, lobby them. You know, we really need this stuff.
So other questions for Scott or comments? Well, I think we're about out of time, guys. So if there's nothing else, we can probably say good night and thank you to Scott for such a great presentation.
Now, I was expecting Joe Yetter to log on. Has he showed up?
I've not seen Joe.
Okay. All right.
Yep. I'll look again. Unless Joe's on the phone, which I don't see another phone number. So, Joe, are you with us? Yeah, it doesn't look like it, Scott.
Okay.
All right. Well, thank you, folks. Much appreciated. Everyone's hard work. And this recording will be available through Scott and any other place you want to put it as soon as I can send it over to him. So you folks take good care and have a wonderful rest of the week.
Thank you. Thanks,
Thank you,
Cap.
Scott.
Thank you.
Thanks so much.